All right, so the first part of graphing the tangent function, I just want to explain where the tangent function comes from. We know that tangent is sine over cosine. So up here I have the sine function graphed and the cosine function graphed. Okay, so we're going to go along this x-axis, which is this axis right here, and read the y values to figure out what the sine over cosine would be. So at 0, sine over cosine would be 0 over 1. 0 over 1 is 0. So at 0, I'm here at 0. At pi over 4, which is right here between 0 and pi over 2, both of them are right here and they're together. That's at pi over 4 is 45 degrees, right? So they're both square root of 2 over 2. So square root of 2 over 2 divided by square root of 2 over 2 is 1. So at pi over 4, they're up here at 1. Sine over cosine. Okay, and we continue on to pi over 2. At pi over 2, sine over cosine is 1 divided by 0. What's 1 over 0? Undefined. You can't do 1 over 0. So on a graph, whenever we have something that's not defined, for all of pi over 2, we say, okay, this is an asymptote.
Okay, I understand.
Next, at 3 pi over 4, which is right in between these two, sine over cosine. Sine is square root of 2 over 2. Cosine is negative square root of 2 over 2. So dividing those two y values, we get negative 1. Okay. Here at pi, right, I look at sine over cosine. So sine is 0. Cosine is negative 1. 0 over negative 1 is 0. At 5 pi over 4, which is right here, they're both exactly the same again, so they're both negative root 2 over 2. Dividing them, what would you get? Positive 1. And finally, at 3 pi over 2, now we have negative 1 over 0, which is undefined. So we start seeing this graph start to repeat itself. So what do you think happens here at negative pi over 4? See, at 3 pi over 4 we had a negative 1. So at negative pi over 4, it's going to be negative 1. And what do you think happens at negative pi over 2? It's undefined. Okay? So these tangent functions, they don't have a max or a min. The functions continue on. Oh, that's the worst drawing. It just continues on through them. And this is the parent function, okay? And then this just keeps repeating and repeating and repeating. Just like sine and cosine go on forever, the tangent functions will just keep going like that. They kind of look like a cubic function.
Yeah.
Only they have, like a cubic function can forever go to the right. These stop at their asymptotes. Or they approach their asymptotes. Okay, so the general form of a tangent function is a tan b times x minus h plus k, where h is still moving right and left, k is still moving up and down. Now, to find the period, think about what we just saw. In the parent function, those asymptotes were between negative pi over 2 and pi over 2. Okay? What's the distance from negative pi over 2 to pi over 2? It's just a single pi, right? Whereas a sine and cosine function to complete one period was 2 pi. So it's half that distance. So the period we find, instead of 2 pi over b, it's just pi over b. So that's one of the major changes between tangent and sine and cosine. The increment, though, is still found by doing the period over 4. To plot the vertical asymptotes, you start at h. Okay, start at h, and then go 2 increments to the right. And 2 to the left. There you'll have vertical asymptotes. Okay, if you have a positive a, if this is positive, then the graph will increase. If it's a negative a, it'll decrease. Finally, those points that we plot on these things, like the three, we call those critical points. The first example that we're going to do is y equals 3 tan 2x. All right, so let's just start thinking about the things that we know. What's a?
Just get a graph paper.
A is 3. B is 2.
This is the greatest thing.
Okay. If b is 2, what's the period? Period is just pi over b, so that'd be pi over 2. All right, so if the period's pi over 2, what's the increment?
Pi over 8.
Yeah, pi over 2 times a fourth. So that's pi over 8.
Yeah.
Okay. What does h equal?
0.
H is 0, and k is 0. Okay, so we're going to graph this over 2 periods, okay, just so we get used to doing that. So I'm going to draw out my function here. Now, the very first thing that we always plot is what? H. And h in this case is 0. So since h is 0, okay, that's the y-axis. So you can actually go ahead and make this the y-axis. Sometimes you don't know where the y-axis will be until you add and subtract your increments. Okay, so I've got my x-axis and my y-axis. Now, my vertical asymptotes. There'll be 2 increments to the right and 2 increments to the left. So 2 increments to the right, I draw a vertical asymptote. And 2 to the left. So if you think about it, if I want to graph this over 2 periods, I just put another 4 notches. 1, 2, 3, 4. And at that fourth, I'll have another vertical asymptote. Now, the period is pi over 2. So the distance from this asymptote to this asymptote is pi over 2. Okay? The increment is an eighth. So I'm going to add an eighth. That'd be pi over 8. Or it's pi over 8, not an eighth, but you treat it like an eighth. 2 pi over 8 is pi over 4. Going the opposite way, you have negative pi over 8 and negative pi over 4. So looking at this, look, from negative pi over 4 to pi over 4, that's a distance of pi over 2, right? A quarter plus a quarter is a half. And then let's just keep counting. So 1 pi over 8, 2 pi over 8, 3 pi over 8. Oh my gosh, look at that 3. Okay.
Is yours trash today?
3 pi over 8. 4 pi over 8 is pi over 2. 5 pi over 8. 6 pi over 8 is 3 pi over 4. Now, the a is 3. So, since it wasn't shifted up or down, so from 0, I'm just going to go to 3 and negative 3. Okay? So, will this graph increase or decrease throughout these points? Increase. So it's going to rise through. So one of my critical points is at negative pi over 8, negative 3. Then my h is the middle of the tangent, and then pi over 8, 3 is another critical point. And then it just repeats itself in the next section. So
Okay, so it's
You
always
can
gonna
just-
look like this little S thing.
okay, and then just draw the graphs through these points.
Shane lives to take my thunder.
Hopefully your graph looks a little bit nicer than mine.
It does, yeah.
The next example that we're going to look at is y equals tangent pi over 4x plus 2. I don't have to factor out this pi over 4 because there's still no h. So here we have a is equal to 1. B is equal to pi over 4. So the period would be pi divided by pi over 4, which is the same thing as pi times 4 over pi. So the period is 4. Okay. Divide that by 4 to get my increment. Well, my increment is going to be 1. We have an h of 0, and the k is 2. So I'm going to draw my x-axis. Okay. For this one, let's just graph through one period for this problem. The next one we'll graph through 2. So I always start with h. That's my very first x value. Well, h is 0, so I'm going to go ahead and draw the y-axis because that's 0. Okay. From h, I can go 2 increments to the right and 2 to the left and draw asymptotes. Okay. The increment is 1. So this is 1, 2, -1, -2. And look, from -2 to 2, how far is that? 4, right? Which is my period. Good. Now it was shifted up 2. So my middle point, this is here up here at 2. Okay? And if a is 1, what's my low critical value as far as the y goes? Be down here at 1, right? And then the other critical value will occur at 3. Okay, so getting shifted up 2 brought my middle point up to 0, 2. And then now my critical points are at -1, 1 and 1, 3. And if you wanted to, you could continue this on either to the left or to the right, however many you want it to go. So, however many periods. Okay. Again, these points are called what? Critical points. Okay, in the last example we have y equals -5 tan of pi over x minus pi, or pi over 3x minus pi over 3. So I have to factor out my b. So I have y equals -5 tan pi over 3. So each thing is being divided by pi over 3. That leaves me with x minus 1. Okay, now I start labeling the things that I know. A is -5. So this time, this graph is going to decrease because it's negative. B is equal to pi over 3. The period is pi over 3, right? So that's the same thing as pi times 3 over pi. So what's the period? 3. With an increment of 3/4. Okay, this time we have an h. H is equal to +1, and the k is 0. Okay, so let's graph this over 2 periods. Now, anytime that you have an h, you have to be careful to not draw the y-axis until you label all your increments, because you don't know like where it might go negative, right? So, so first thing I'm going to do is just draw the axis. Okay, and my very first point that I'm going to write down is my h. So here at 1. Now I know that 2 increments to the right and 2 to the left, what occur there? Asymptotes. Now, this time, let's do over 2 periods. So 1, 2, 3. Didn't really give myself enough room, but that's okay. it'll just not drawn to scale. Okay. The increment is 3/4. So you can think about it this way: 1 is 4/4. So adding 3/4 to that would be 7/4, 10/4. Right. I'm just going to keep adding 3/4. Now, why am I writing it at the bottom? So I can reduce them in a second. 13/4, 16/4, 19/4, 22/4. And then moving the other way, 4/4 minus 3/4 is 1/4, and negative 2/4. Okay, as soon as I switch pen colors, though, it's not going to let me erase. But let's go ahead and just reduce those. So that's negative 1/2, 1/4, 7/4, 5/2, just reducing these things. 13/4, 8/2 is 4, or just 16/4 is 4. That's easy. 19/4 and 11/2. Oh, and look at that, it's letting me erase. Okay. So now we can see where the y-axis would occur. Okay. The y-axis is going to be between negative 1/2 and 1/4. So I'm going to draw in my y-axis. There was no shift up or down, so I know that this thing is going to go up 5, or my critical values will occur with a y value of 5 and a y value of negative 5. Okay, so finally we're able. Now we're ready to draw the graphs. The graph is going to fall through. So we have the asymptote. The next thing was 1/4. I'm sorry that that looks like a little negative sign. Here, I'll fix it. There. So it's going to fall through. So we have up here at 1/4, 5. That's a critical point. HK is that middle point. So the H was 1, K was 0. 7/4, negative 5. And then just repeats itself in the next period. Yeah, this graph falls through because it's a negative tan. Okay, and that's how we graph the tangent function with transformations.